Good morning, fancy meat computers! How is everybody doing on this terrible, terrible Monday? It is just the worst Monday I have seen in a few weeks at least. So, how's it going? How's everybody doing? Doop, 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 doop. We've got 3 people watching right now. Is it midterm week for you guys or something? Or am I just impatient? Am I impractical? Irresponsible? Boop, 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 boop. Yes. Happy Monday. Or as Garfield would say, Happy Monday. Let's try to be a little higher energy than Garfield today, shall we? Let's see, where are we? Pointers! Pardon me. Right. Gotcha. Alright. I can see this being incredibly useful for test cases, though. I can just create a set of test cases and a function that just runs through said test cases through the input function. Yeah. Yeah, it's like lots of people get very excited about like fancy things like functional programming, and it's like C can do that. C can do anything. You just need to know how to do it. Yeah, I think we've got a small section on function pointers coming up. So yeah, I'd like to get through as much of this as possible today because time. The hour grows near at hand. The witching hour is near at hand. And, tests and midterms cross the land. Including ours. Oh, no. Don't you hate it when you burn your tongue? Terrible. Alright. So, nothing really to announce, so let's get right into it, shall we? So last time we were talking about passing pointers, how you can pass an element by reference if you pass a pointer to it. This allows C to follow that pointer back to the original context wherein that data is held, which is a fun little way for C to have implicit arguments and return values. So in C, we will occasionally, like once we get into the functions over strings, which are in the standard library, we will notice that these functions are using pointers in order to return more than one thing from a function, because that's the sort of thing you have to worry about. It's like, if we are concatenating a string, it'll often just put the concatenated string into the slot for the first string, and then, like, return the number of characters it successfully concatenated, or something like that. So, it'll be useful, forward into the future to use pointers in order to return multiple things from a function. But yeah, let's see here. Next week midterms start. Oof. Crazy how like all of my roommates had last week and this week for midterms weeks. Yes. Whereas those are the only 2 weeks that I don't have midterms. Woof. Oh, yeah. Software engineers have only one midterm per course for the most part, and almost no midterms in November. Then there is Tron. Yes. Yeah. Yeah. But hey, I'm pretty sure Tron has a higher entrance average than Software Eng, right? Pretty sure. Usually, Tron is harder to get into. So, in theory, you guys are smarter and therefore more capable of handling the workload, right? So, yes. So, 3 midterms each for dynamics and statics. Yes. Yeah, they do so like to give you tests when it comes to mechanics, don't they? Oh, it was 0.1 points lower this year. Oh. Well, engineer equals God complex. I mean, engineers do rule the world. You don't see that. It used to be that you would walk around campus and people would just have written ERTW on every building, like as graffiti. But, yeah. Your schedule is making you lose motivation. But Christmas is so close. You just have to make it through the next 4 weeks, and then make it through exams, and then, like, 5 more semesters, and then you're done! You can do it! But, anyway. Okay, so, not to belabor the point too much, I've already talked about this a bit, but arrays are pointers. The syntax for passing an array is as an argument to a function is the same as passing a variable by reference. This is because the compiler does not differentiate between pointers and one-dimensional arrays. They are the same thing. Like so many things in C, this means that it's our job. It's up to you to write your functions so that they are using their argument as intended, but y'all should be used to that by now because you've been trained in Python programming, so you should be well familiar with the idea of duck typing, right? So, wait, 2MP3? That's this class. What? No tutorial for 2MP3. Pardon me. I'd just like to check my Slack messages, see if the TAs said anything to me about that before they went and canceled their tutorial. Nobody said anything to me about it. So, This class's midterm should be fine. Don't really need to study per se. Okay. Yeah, that's fair. So, anyway. Because it's up to you to write your functions in such a way that their arguments are being used as intended, documentation is critical. It's on Teams. Oh. Well, I'll hear about it afterwards. So an array is actually a pointer to its own first element, right? That's what, like, once you have stepped out of programmer land and into compiler land, that's how things are actually handled at the level of the compiler and at the level of the object code. So, okay. Alright. I'm gonna look at Teams and see who and why. Let's see here. Handling a personal emergency. Yeah, okay, that usually, like, okay. Extension requests, extension requests. I get so many extension requests. I know the midterm is a take-home 24-hour test, but how long is it actually intended to take? I'd say anywhere between 2 and 3 hours. Is the midterm something we can work on for 24 hours straight, or is it something we can start at any time in the 24 hours but only have 2 hours to do it once you start? The first one, 1 minute to push to get. Yes, very true. Very true. So, normally, what happens in situations like this with TAs, I assume that, I assume that Chev is in some kind of difficulty, so, you know, we'll probably still have the tutorial, but later in the week, except it's probably a scheduled one. Okay, just go to the online tutorial this week if you're in that section. Like, jeez. Monday morning and my email is already blowing up. Anywho. So arrays are pointers to their own first element. We can perform arithmetic on pointers in order to traverse arrays without using the indexing operator. If you have another midterm on the same day, send me an email about it. Like, I'm assuming that not all of you have a midterm on the day that I've scheduled for the midterm, which I scheduled specifically on a Saturday so that there wouldn't be any conflicts with any other classes. I assume that's just you. So, const and the art of mental stillness. Problem: whenever we work with pointers, there's a possibility of pointer misuse, resulting in a segfault. We can prevent arguments from being modified by using the const qualifier. So, for example, const int pointer foo float pointer bar, right? So in this case, foo has been locked. It has read-only privileges, whereas bar has read and write privileges. That's the best way to think about const, the const keyword, as restricting write privileges. So if you try to write to foo, you'll get error, assignment of read-only location, which of course is nice. That's a good one. Trying to modify a const argument will result in the following compiler error. So this is a compiler error, so this is checked at compile time rather than at runtime. Using const to restrict functions from modifying things they shouldn't modify is good software design. Again, it feeds into the idea of principle of least privilege. In general, a program should only have enough data access to accomplish its task and not one smidgen more. Yeah, I haven't designed the midterm. Well, to be honest, I'm still in the process of designing the midterm, but I have not designed it such that you will need 24 hours for it. Again, well, it's kind of interesting, right? It's like, if you give people a 24-hour window, I find people, like, aren't in a hurry to get it finished. So there's a tendency to take more time with it than you would take if it were a more tightly time-constrained midterm. So, like, you know, I'll often hear people taking, like, you know, 6 or 8 hours to do the midterm, and I'm like, wow, that's way too long. You know? You definitely, if you were actually, like, burning your butt on it, then you would probably have gotten it done in 2 or 3 hours. But, you know, people sometimes appreciate the ability to take longer with it. I don't know. The reason I do it is I do it that way is because people who are in different time zones, like if I set a midterm for any particular, like say I made it for like 2 o'clock in the morning, right? Or sorry, 2 in the afternoon. Like for some poor guy in China, that's like 3 in the morning, which is, you know, I don't want this course to contribute to you guys feeling like you need to have an unhealthy lifestyle to get through university. I don't want it contributing to that any more than just being in university contributes to having an unhealthy lifestyle. So, you know. Anyway. So, that's true. C, pointer arithmetic. So, hey, C, could you zero out these addresses? Sure thing. Poof. Wait, what did those addresses point to? Looked like some kind of critical OS data, kernel, or some such. What? Meh. This is C's attitude in general towards everything. C doesn't care. It'll do anything you ask it to. Yeah. Yeah. So, you know, I used to do paper tests, actually, for programming. I used to do paper tests before the pandemic, but I really, like, I was concerned when I started doing, like, the take-home test format that, like, everybody would get perfect and there'd be no point in doing tests anymore, and, like, academic dishonesty would be a huge problem. But between the Moss checking on academic dishonesty, which is actually really, really solid checking, and, you know, the fact that I set these midterms and people still don't get perfect on them, you know, I've developed a system whereby this works, and I actually think that it's better to test programming skills in this way because, like, you know, I used to get the argument from students, well, realistically, if I were required to perform a programming task, it's reasonable to expect that I would have the internet available and I'd be able to look up errors on Stack Overflow. And, you know, I used to be like, but midterms, though. But now it's like, yes, yeah, I think that makes sense. You know? So, anyway. So here's a program illustrating array addressing. So we declare foo, which contains 5 elements. We declare bar, which contains short ints, right? They're being declared as floats for some reason. Weird. So for I equals 0, I less than 5, I plus plus, we are printing the address of I, right? We're printing I here inside of the square braces, and, excuse me, the value of the pointer as we're incrementing it through, and also the result. No, actually, we're not printing the result in this case. So, and we're doing the same thing with bar, same exact procedure. So, if you do that, foo, as you increment the pointer, right? This is our first view of pointer arithmetic, right? So this is basically what we're doing is we're using indexing to access the different elements of the array, and then we're seeing where that sits in memory, right? So for the midterm and exam, we'll be allowed to access internet/textbook/class resources. Yes, just don't do an academic dishonesty, please. Especially on the exam, because, you know, cheating on the exam, I have to then make the decision whether I'm just giving you a 0 on the exam, which is probably a flunk right there, let's be honest, or if I'm, like, doing the transcript notation thing for you. Yeah, I actually prosecute academic dishonesty, don't you know? You know, my understanding is that, depending on the class, they might, you know, They may or may not actually pursue charges, but I do, so be aware. And just don't cheat. Easiest way to not cheat is, the easiest way to not get caught for cheating is to not cheat. So, so the address of the first element is like this long pointer with a 0 at the end. The next element in the array has a 4, then 8, then C, and then 0. So you might be able to notice a pattern here. An integer is 32 bits. A 32-bit integer is 4 bytes long. You'll notice that the spacing between this addressing is 4 bits, or 4 bytes, sorry, 4 bytes. So the memory then is being addressed to the byte, right? If we take a look at bar, which is a short ints are 16 bits, that is 2 bytes. We start at a particular index, and you'll notice that the address of each of these elements goes up by 2 each time. There you go. What's the transcript notation? It says F assigned for academic dishonesty on your transcript, and you can never get rid of it. So any employer that you show your transcript to is going to see that you got a 0 for you got an F for academic dishonesty. Yeah. Oh, and in grad school, there's no first offense, first warning. It goes straight to flunk the course for any incident of academic dishonesty. Our old friend plus plus. Notice in the previous slide how foo's memory addresses are 4 bytes apart and bars are 2 bytes apart. The array is continuous memory, and each element is allocated the size of the base data type of the array. If we wish to perform pointer arithmetic to traverse an array, we need to show how big the steps are. Control-Shift+I to edit transcript. Yeah, employers will often request a written embossed copy in a sealed envelope. So have fun trying to Control-Shift-I that one. And you have to pay for those, by the way. So, operators can mean different things when applied to different arguments of different types. Obviously, there's a big difference between integer and floating point division. The increment operator, when applied to a pointer, will automatically take the size of the data type it's operating on into account. So, here is our first example of pointer arithmetic. Char foo is the string dated reference. So we also declare foo pointer, a character pointer. That character pointer has the address foo. So foo, because it's a character array and we've left out the square braces, this is now a pointer. It's a character pointer, right? Because arrays and pointers are the same thing. So this is not incompatible. While dereferenced foo pointer is not equal to the null character, printf brace character end brace of foo pointer plus plus. Notice we are incrementing a pointer here, right? And then we print a new line. So our output here is dated reference, but with braces around every character except for the null character. So this is kind of interesting, right? Because normally what you would have to do here is you would have to like know the size of the data structure, and you would have to have a separate counter I going, right? And you would have to you would use array indexing to access each of the individual elements. Here, we are not using an array access operator anywhere inside of the loop. Instead, we are just moving the pointer to the next element of the array, the next element of the array, and dereferencing as we go in order to read the thing that we're reading. You see how much this looks like a Turing machine? It's almost like computers were designed in order to implement the universal Turing machine, huh? So, the following operators are valid on pointers. These are actually the only operators that are valid on pointers. You've got plus plus, minus minus, plus minus, plus equals, and minus equals. Minus is not extremely useful. It's not very useful. But anyway, in each of these cases, the number that you are adding or subtracting to or from the pointer is implicitly multiplied by the byte width of the data type. So, if you are performing plus plus on a short int, that will add 2 to the address. If you're doing it on an int, that'll add 4 to the address, and if you're doing it on a long int, that'll add 8. 8 to the address. There would be a 0 at the end of the line, that line there, after the dated reference. In this case, no, because this is, like, I'm ripping this straight from standard output, so there might be null characters after each one of these, because this is a string, right? So it would have a null character right here. So you'd have a null character between each of these, but they don't show up. So, 2 questions. If you do %, p foo pointer plus plus, would it print out each memory location? Yeah, it would print out the memory location at which each one of these things is being stored. Why was the null character the condition for the while loop? So, with respect to strings, when you write a string like this in C, you always have this character as the last character here implicitly, like after the end of the E. Anytime you write a string, the null character gets put at the end, right? So, an efficient way of telling if you're at the end of a string is to look for the presence of the null character. This is actually how the C standard library, that's how the standard library performs string operations, is by checking to see if you've hit the end of the string by seeing if you have the null character there. Would it add 1 to the Boolean address, or is that sort of useless? I don't know, what Boolean... Do we have a Boolean here? You can have Boolean pointers, but it's, like, kind of silly. Is there anything at the end of an integer array implicitly, or is it just strings? It's just for strings. There's nothing at the end of an integer array implicitly. And when you do a character array, if you actually do the character array out character by character, you don't get the null character at the end unless you put it in there yourself specifically. Like, I had a meme. Where's my meme? I had a meme about this. This is a meme. There you go. So these two are completely these are exactly equivalent in C, right? Hello world, note the presence of the null character. If you do it like this, you have to include the null character yourself. Yeah. Yeah. Incidentally, apparently, so I've some of you who are subscribers to the channel may have noticed that I had community posts unlocked for my my account recently, and I've just been flooding the internet with memes. And someone, I think from the 1MD3 class, reposted some of my memes to Reddit, to r/programmerhumor, and they got like 2.9 thousand upvotes and were like on the main page. I was very proud of myself. So now that's only going to encourage more memes, you realize. But it's funny because like I got a bunch of people on Reddit angry because I said that Minted is trash and that listings is the best for like doing code in LaTeX files, and it's like people have opinions. Holy smoke. Anyway. Apparently I'm officially designated a meme lord now. watermark my memes then. Nah, dude, come on. If I watermarked my memes, then I wouldn't be able to like sneak ones in that I'd stolen. And besides, that's kind of the whole point of meme culture, right? Is like, you know, repost, you know? Take this and repost it if you like it, you know? Like, the freedom, the meme freedom, it's like, you know, anyway. If int pointer x equals array, then when I do x plus 2 dereferenced, it's just implicitly multiplies but the 2 by the size of the int in the bytes and moves me 2 index spots in the array. Yes, correct, David. That is how it works. Yeah. Oh, it's currently at 3.3 updates. Awesome. Yeah. Well, hey, if I can scrape together another 150 subscribers, then I can monetize my channel, and then I can, you know, make like 10 cents a month on old video ad revenue. So, for example, if pointer points to an integer, then pointer plus equals 4 would move the pointer by 16 bytes, since the bit width of integer is 4 bytes. Pointers may be subtracted from one another as well, but only meaningfully if they point to the same array. So if you've got two pointers that are pointing to the same data structure, this is meaningful. Otherwise, it's not. Personally, I've never actually been able to get it to work, so, you know, mileage may vary. Pointer subtraction is provided with absolutely no warranty. Yeah. So, a word to the wise. In the previous example, tracing a character array, we used knowledge that strings are null terminated to set a stopping condition for our loop. Pointer arithmetic can easily place a pointer outside the bounds of its original data structure. This is very easy to do. There's no built-in protection against out-of-bounds pointers, so we can easily use them to assign to memory outside of the array bounds. This could overwrite other variables, cause segmentation faults, and many other troubles. While desktop operating systems protect against this sort of thing, embedded systems do not always have these sorts of protections, especially older ones. So, long story short, C is not going to hold your hand. It's not going to tell you when a pointer goes outside the bounds of the data structure that it's supposed to be pointing to. You just have to keep track of that yourself. You have to write your algorithms correctly. So, wildcard pointers. Normally, pointers require compatible types to be assigned to each other. The exception to this is the void pointer. So, for example, you couldn't assign a character pointer to an integer pointer or vice versa. However, if it's a void pointer, that works. So, the void pointer is a generic pointer that can point to any data type. This might actually give you some interesting insight into how the void data type works in C. So normally pointers carry with them the information of like how big the thing is that I'm how big is the thing I'm pointing to, so that A, I know how many bytes to gather to return from a dereferencing operation, right? It's like if you're dereferencing an integer pointer, you have to grab 4 bytes. If you're dereferencing a short int, you only have to grab 2 bytes, etc., etc., right? So the pointer carries with it that information. Void pointers essentially say, I carry 0 bytes. So you can't perform integer arithmetic over a void pointer. This is a generic pointer that can point to any data type. A void pointer is compatible with all data types and may be used in assignment operations freely, The catch is that void pointers may not be dereferenced. Because a void pointer doesn't know how big the data is that it's supposed to be dereferencing, it can't dereference it, right? You can't return 0 bytes. This is because the dereferencing operation uses the byte width of the pointer's data type to select the area of memory to return. So, so with a void pointer, so how are these things even useful then, right? And the answer to that is you cast them. If you want to, like, when you have like certain functions in the standard library that can return a pointer of, you know, a number of different data types, they will tend to return a void pointer and expect you, the programmer, to cast that pointer in terms of the data type that you want it used on. So, and just a little bit of miscellaneous information. Equality and relational operators work on pointers. So if you want to tell if something's like higher up in memory than something else, you can use a relational operator on it. Relational operators are only meaningful if the pointer refers to the same data structure, and equality comparison with null is actually quite common, right? In fact, you'll have already seen examples of this previously where we've compared a pointer to null, right? Array indexing is actually just syntactic sugar for pointer arithmetic. So this is true. When you say, I want foo at 3, the fourth element of foo, what you are actually saying is foo plus 3 dereferenced. This is syntactic sugar. By the way, if you haven't heard of the phrase syntactic sugar, that just means it's something that you can do syntactically that the compiler will transform to other operations, which is provided primarily for your convenience as a programmer. Therefore, it is also possible to index pointers in the same way as arrays. Yes, so you can actually use this notation on a pointer, but generally speaking, you wouldn't. Because generally speaking, if it's an array, you use it like an array. If it's a pointer, you use it like a pointer. It's not good to mix it up too much because you might forget what's a pointer and what's an array. One of the few differences between pointers and arrays, pointers and array identifiers, is that an array identifier may not be assigned to. We can think of them as read-only pointers. So, when you declare an array, there's like an implicit const that's being applied to it as well. So the pointer itself can't be modified. But yeah, so... And this is an interesting thing here because, you know, have you ever been programming and wondered why everything is 0 indexed? You know? Why in Python or Java, when you declare a list or an array or whatever, the first element is 0? Have you ever wondered why the first element is 0? This is the reason the first element is 0. It's because foo, by default, foo plus 0 is the first element of the array. Foo plus 1 is the second element of the array. Foo plus 2 is the third element of the array. This is why 0 indexing. Just in case you were curious. Because I know that's like a tripping hazard for a lot of people learning programming, right? So, how could I function without pointers? Things that are true. Pointers point to memory addresses. Functions are stored in memory. Ergo, pointers can point to functions. Bum-ba-da-dum! In C, a function name is really the starting address of the function's instructions. Pointers to functions may be A, passed to functions, returned from functions, stored in arrays, and assigned to assigned to other function pointers. Pointer arithmetic doesn't make a lot of sense for them, though. It doesn't make a lot of sense to do pointer arithmetic on functions, on function names, but you can pass functions to functions as arguments which basically, considering how a lot of programming languages are calling themselves multi-paradigm because they allow some functional constructs these days, this technically means that C has been a multi-paradigm language for a long time. So, yeah. Oh, the only annoying thing is that MATLAB and Maple both start indexing at 1 instead of 0, so I keep referencing elements that don't exist. Oof, yes. So we couldn't modify the value inside of the array using pointers. Like, could we do dereferenced foo plus 3 equals 5? Yeah, you could do that. Yep, that's valid. Yeah, no. You can dereference a pointer on the left-hand side of the assignment statement, and that means that you're writing to the inside of... You're writing to the memory element that the pointer is pointing to. Yeah, so, and you can do the indexing. It's like, think about it this way, right? If C actually does transform this into this before it compiles it, you can put this on the left-hand side before an assignment equals, right? So this is also valid. Yep. So, in some programming languages, notably Haskell, passing functions as arguments to functions is commonplace. Just like most things in C, C can do this too. You just need to be willing to use some elbow grease. So, this is how you do a function pointer. If we have void bubble sort, which, you know, this is like this is a bubble sort algorithm that's using a custom function to decide basically greater than or less than. So we are making the fourth element of foo 5. Yes, just like if foo open square brace 3 close square brace equals 5, that would also set the fourth element of foo to 5. So the third argument is declared as a pointer to a function, taking 2 integer arguments and returning an integer. So basically, you have to put like the function's type signature into as an argument inside of the list of arguments to another function, and you also have to include you have to open a brace star and then give the function a name. So this is a name that you're deciding for the context of this function. What this does is this binds the star operator to the function name that you're declaring. If you didn't have these braces, it would bind to int, and it would think that this was an integer pointer instead of a function pointer. Compare is the identifier we are giving the function, and the parentheses bind star to the function name. Without them, this would be interpreted as a function returning an integer pointer. Precisely. So, this is how it works in the big bubble sort example. So, bubble, you've got the array you're working on, size, and the integer. You've got the function pointer. We then have 2 functions, ascending and descending. Notice that my gosh, it's really windy out there. Jeez. Their type signatures are the same as the type signature that has been declared for this function pointer. So unlike Python, where you can just slap a function in there willy-nilly, in C, you do still need to maintain your static typing properties. So you do need to make sure that the return type matches and the argument list matches whatever function you give to the function as a function pointer. So, good. This is just like, give me an array, use bubble sort on the array, right? So basically what this program is doing is it's prompting for if you're sorting it in ascending or descending order, and if it's sort it in ascending order, then it passes the ascending function name with no adornments, into the bubble function itself, right? Otherwise descending, and we have definitions of ascending and descending. They're very basic. It's just, compare two elements. If B is less than A, this returns true. If B is less than A, that gives you ascending. And in descending, you do the reverse. So inside of bubble itself, you take compare as a function pointer, right? If then you use it here, if compare, and then you compare the two elements, right? It'll return a Boolean, so that satisfies the if statement. Notice, however, when we are dereferencing the function pointer, we are using the same structure where we need to include the parentheses around it to bind the dereferencing operator to the function name, right? Because otherwise, basically the problem here is that function call binds more tightly than pointer dereferencing, right? So with this, if you didn't have the braces here, passing these function arguments to compare would bind more tightly than the dereferencing operator, so that would be performed first. In order to get this to work, you have to bind the dereferencing operator more closely than function application. But yeah, so as a result, we would get the following. If we had so enter 1 to sort in ascending order, 2 to sort in descending order, we enter 1, and you can see that sorts things in ascending order. Similarly with 2, it gets into descending order. So there you go. So I kind of explained all of this already. So I'm going to skip that slide. Just like everything else, we can organize function pointers using arrays. So if we have integer with a function pointer, the third element of a function pointer, which takes int and int, and we can put 3 function names into an array. So yeah, so we can have arrays of functions now, which is kind of cool because functions are now abstracted to the point where we think of them as being memory addresses, and memory addresses can be put in arrays. So there you go. To declare an array of function pointers, once again, we bind the dereferencing operator, or in this case, the pointer construction operator, to the identifier with parentheses. Additionally, a list of argument types is provided immediately afterwards. The 3 ints above indicate the function's typing information. In this case, all functions in the array accept 2 integer arguments and return an integer as output. Array sizing follows normal rules. Since function identifiers are pointers to functions, we can use them directly to initialize the array. So there you go. I'm going to skip this example because we need to keep moving. So, basically what's going on here is we've got 3 functions, and the user is prompted to choose a function, and whichever function, like these functions are void and they take an integer, and they basically just, they just do a print statement saying you called function 1, you called function 2, you called function 3. So, this is just to demonstrate that it works. But yeah. There you go. It works. So. Oh, crap. I think we're out of time. I will answer your questions and then get the heck out of here. Next time, we will talk about dynamic memory allocation. So the 2 ints in parentheses are the input slash parameters, and the int at the beginning is what the function returns. Where is it? Yes. This is the return type. This is the argument types. Yes. Again, You can do similar things to this in Python. However, because Python uses duck typing, you're not required to have a particular particular type signature when you're passing functions around like this, which is another reason why Python is terrible. Whereas in C, everything has to be statically typed, right? So if you try to provide a function that has the wrong type here, it'll probably give you a pointer incompatibility warning. And of course, we all listen to all of our warnings in this class. So Python uses duck typing. Yeah. So duck typing is if it looks like a duck and it walks like a duck and it quacks like a duck, then it's a duck. Right? So in Python, basically, that's like a complicated way of saying, in Python, things have the type they're used as, you know? It's like you don't declare types when you're using a function in Python. You can provide what are called type hints, which are more for the user than Python itself. But like Python itself uses what's called type inferencing, right? Nothing is explicitly typed. Literals have types, but, you know, the typing on literals in Python is pretty flexible, right? An integer can be used in combination with a floating point number, for example. So basically what it does is it uses typing inference rules to sort of calculate what it back calculates what like the argument to the function should be based on, you know, the argument that it's being used. Yeah. Like if you code y is equal to 2 over 3, you don't need to define double, and you don't need to define it as double. That would be duck typing. Yeah. Basically. Although, like, most languages use some degree of type inference, right? Even C will use a certain degree of type inference. Where you really start to rub up against it is with function declarations, because Python, for whatever reason, decided that no types should need to be declared ever for any reason, particularly as applied to functions. Like most languages they'll get nasty with you if you try to provide like the wrong types as arguments to the functions. Most of the time that's just a compiler error in most languages, but in Python it's like the argument is assumed to be correct, right? And basically what that does is it defers the problem of passing the wrong type to the statements inside of the function. So if you've passed like a boolean in and you're expecting an integer, you'll get like a type error as you're executing the function. It won't detect it up front, which kind of gets into like the fact that it's an interpreted language and not a compiled language. But yeah. So why are there two integers? Those are the types of the two arguments we're expecting for each of these functions. Yes. Oh wait, so all the functions in the array there take two int values for arguments. Yes, sorry, I didn't get to that. So I'm assuming that all functions in Python are technically void. They're void. One way to think about it would be they're void until you return something from them. Then they have the data type of what you returned from them. But this is why in Python it's totally and completely possible to have a function that returns, like, you know, 5 different types of things, right? Which is stupid if you like to think about programs in a mathematically rigorous manner. That's the stupidest thing ever, is to have a function that could return different data types depending on how it executes. But, you know, that's Python for you. It's easy to learn. because you don't have to follow rules, apparently. What is the best way to prep for the midterm? I know the answer is practice, and if so, would you post practice problems? Send me an email about it. It would be reasonable to expect you guys to... Like, it would be reasonable for me to post last year's midterm for you guys. Also, is there any reason why the main function, at least in this course's assignment, always returns int? What is that standard? You can sometimes have, like, it returning void, but that basically gets into how it interacts primarily with Unix. So, sometimes if a... If a program has a problem, it encounters a problem, it has an error or something, ordinarily the way that C programs tell their operating environment that a problem occurred during execution is with quote-unquote non-zero exit status. So if the program returns 0, that tells the operating system that it computed, executed, and terminated normally. If it returns a non-zero exit status, then it had an error or encountered some other problem, and, you know, various programming, like various programs will have various error codes that indicate various types of problems that could occur. Like, for example, if you were to call GCC on a program that had a syntax error, GCC returns a non-standard, a non-zero exit code, which incidentally is used by us in the auto-grading software. So, like, when we auto-grade your assignment submissions, the first thing we do is check to make sure they compile, which we, like, batch process all of your assignment submissions and, like, basically run them on run them through GCC, watch for a non-zero exit code, and if you get a non-zero exit code, like, we just allocate 0 for that test case, right? Yeah. In general, would all the functions pointed to need to have the same number of and types of arguments? Yes. In C, yes. So that's why if you're checking for errors with a Linux shell, it returns an integer. Yes. So, I kind of make this joke sometimes that, like, your operating system is your integrated development environment. Like, your operating system is your IDE. And that is more true for C than for any other computer language, especially if you're on a Linux operating system. Like, Unix, on which Linux is based, right, was co-developed with the C programming language. Remember from our early lectures, right? So, because Unix and C were developed in concert with one another, the way that C works is influenced by how Unix works, and Unix basically expects all programs to expect... Unix basically expects all programs to operate like C programs. So that's why, like, you know, like, another good example of this is argv argc, which is the way that parameters are passed into a program. You know, basically argv and argc are the command line arguments that you provide when you call a program. We're going to get to them eventually in this course. So, you know, pretty much anything that accepts arguments from argv argc does it basically in the same way that main does in a C program. And that's because it's like you really do gain a lot by having a standardized interface. But yeah. So if f is a function pointer, so is f a function pointer or an array? It's an array of function pointers. And why is f at 3 and not f at 2? Oh, because I made a mistake. That's my fault. Sorry, yeah, that should be a 2. That should be a 2. Would it still provide an integer exit code if it was a void function? No. Void functions do not provide return values. So if you made main void, basically you're not you're passing up the opportunity to provide a exit status, which means that it probably just puts 0 in, you know? But yeah. Oh, because 3 is the size of the array, not the index. Oh, wait. Did I make a mistake? I might have made a mistake. Let's see. Oh my goodness. Did I just tell everybody the wrong thing? C array initialization. Let's see. C++ should work. Yeah, sorry. Yeah, no, this is correct. When you declare the number here is the number of elements in the array, not the index of the maximum element. Like if you take a look here. Ta-da! There you go. So yeah, anyway, man, I've been gabbing for a while, and you guys have had lots of good and interesting questions, though. I don't mind spending the 10 minutes of break if, like, we were actually talking about programming, you know? I mean, that's what I was thinking, but it could be just completely making it up. Because to declare an array, you put the size of the array, not the last index. Yes, I'm sorry, I had a brain fuzz there for a moment. I forgot how C works. And they let me teach classes. Anyway, I'm going to sign off here. Thank you very much for your time and attention today, folks. Try to stay dry. Don't leave the house if you can avoid it. But, you know, this time not for COVID reasons, just for, like, general terribleness of the day reasons. I bet it's cold today, too. I haven't looked at the thermometer, but, like, geez. Yeah. Cool. Take her easy, folks. Bye-bye.